Here is the solution for day 4. Solve the system of equations by Gaussian elimination method. Here we have 3 equations with 3 variables, x, y, and z. Gaussian elimination method is a procedure for converting these 3 equations into 3 equivalent equations in which the first equation still has all 3 variables, the second equation has only 2 of the variables, and the third equation has only 1 of the variables. The procedure begins by making the first equation in the system start with a leading coefficient of 1. Now there's different ways to accomplish that, but perhaps the fastest in this problem is to take that third equation and write it as the first equation. Now that first equation has a leading coefficient of 1. I'll keep the second equation the same as it was, and I'll take the first equation and write it down here in the third spot. This is equivalent to the original system because we haven't changed any of the equations. We simply changed the order in which they were written down on paper. Now the next step of Gaussian elimination method is to eliminate this x term here. And that is done in the same way as elimination method in the previous Bell-Work problem. When you add together opposite terms, they are eliminated. So what would you add to positive 2x to eliminate the x term? You'd have to add a negative 2x. So what we're going to do is we're going to take negative 2 times the first equation and add it to the second equation. I'm writing down that note to communicate to you what's going on. I'm going to multiply the first equation by negative 2, and then in my head, add it to the second equation to create a new second equation. Here's what it's going to look like. The first equation stays the same. But the second equation is going to get replaced. Let's talk through what's going to happen. Negative 2 times x is negative 2x. Negative 2x plus 2x is eliminated. Negative 2 times y is negative 2y, and negative 2y plus negative 3y is negative 5y. Negative 2 times z is negative 2z, and negative 2z plus 2z is eliminated. Negative 2 times negative 3 is 6, and 6 plus 9 is equal to 15. In doing that step, coincidentally, it eliminated the z term when we were really just trying to eliminate the x term. Now the next step of Gaussian elimination method is to eliminate this x term. And here's how we're going to do that. I'm going to write down in symbols what I'm going to do to eliminate that 4x term. I'm going to multiply negative 4 to equation number 1 and add that to equation number 3 to create my new equation 3. Let's talk that step through. Negative 4 times x is negative 4x. When you add that to 4x, that's eliminated. Negative 4 times y is negative 4y. Negative 4y plus 1y is negative 3y. Negative 4 times z is negative 4z, and negative 4z plus negative 3z is negative 7z. Negative 4 times the negative 3 is 12, and 12 plus the 11 is 23. Notice that I point at terms as I'm working with them, and I'm talking them through out loud in the video, but I would be talking them through in my head if I was working this as homework. At this point in time, because our middle equation has only one variable left, we could solve that for y by dividing both sides by negative 5. We would get that y is equal to negative 3. We could take that answer for y, substitute it into the third equation right here, and that would allow us to figure out what the z is. Then we could take our answer for y and z and substitute here and here to get the answer for x. But we were asked to use Gaussian elimination method, so I'm going to continue with that method just for the practice of doing it. The next step in Gaussian elimination is to make this term here have a leading coefficient of 1. That can be accomplished by dividing by -5. So here's what the system would look like. X plus y plus z is equal to -3, and our second equation is going to transform. If we divide by -5 on both sides, it will become y equals -3. And here's the third equation. Now the next step. We want to eliminate this y term here, so that in the third equation, only the letter z is left. The first equation will remain the same. The second equation will remain the same. It's this third equation that's going to change. Now on top of this arrow right here, let's label what we're going to do. What would you add to -3y to make it eliminate? You would add +3y. So we would have to take 3 times equation 2 and add that to equation 3 to create our new equation 3. Let's talk that through and write down the result. 3 times y is 3y. 3y plus -3y is eliminated. 3 times nothing z is like 0z, and then when you add the -7z, you still have the -7z. 3 times -3 is -9, and -9 plus 23 is 14. At this point, we're essentially done with Gaussian elimination, because we've created this triangular arrangement coming down like this, where the first equation has all 3 variables. The second equation would have 2 variables, except that the z was eliminated along the way, and the third equation has only the variable z. If you want, you could go one more step where you divide both sides by -7 to get a leading coefficient of 1 on the z. We're going to end up doing that anyway to solve for z. We will get that z is -2. In the second equation, we already know that y is -3, and then we can use both of those values in the first equation to solve for x. Let's do that down here. X plus -3 plus -2 is equal to -3. We would discover that x is equal to 2. Here are the solutions for the 3 variables, which we should write as an ordered triple in alphabetical order. 2, -3, -2. Now, Gaussian elimination is a complicated process, so it's easy to mess up. We should check the answer into the original equations to make sure that they really solve out to 11 and to 9 and to -3.